Okay, in our lesson today, we're going to look at how to solve a system of equations by substitution using the substitution method. Our essential question, how do we use the substitution method to solve systems? So please take a minute to set up your notebook and then restart the video. Now, I've given you a couple of steps here to think through. We want to solve one equation for one variable, and it says choose an easy one. So what I want you to see in these two equations, in this instance, one of the equations already is solved for a variable, and that variable is y. Okay, so I'm going to write that equation right here. And one thing I suggest with the substitution method is you do, like I'm showing you, and you write the equations side by side. Because a lot of times we get tripped up with all our work and we lose it and we forget what we've used and what we haven't used. But one thing I want to point out is if I didn't already have a variable solved for, what variables do you think would be easiest to solve for? I hope that you're recognizing it would be easier to solve for maybe this x. This one's already, y is already solved for. This x is easier because the y has a coefficient of 2. And if I try to solve for y, what's going to happen is I'm going to end up with some fractions. And we know how much we love fractions, right? So if, and I'll give you an example in a minute, but if you don't already have a variable solved for, I'm going to suggest that you want to pick the variable that has a coefficient of 1. We're going to see later on that if the equations don't have a variable of 1, that you might want to use a different method than the substitution method. Okay. So now that we've written our equations side by side, and now that we already have a variable solved for, then we're going to substitute the equation from 1 into another equation. Now what I want you to see here is we've solved for y, and y is equal to 2x minus 1. So wherever I see a y, I can replace it with 2x minus 1. So all I did was substitute, hence the substitution method, y for something else. Notice I now have all the same variable. So now this is an equation that I can actually solve. So I'm going to do the distributive property. And this would be step 3. Well, we're still solving, I guess. I'm going to combine like terms. This should all be something you already know how to do. I'm going to add 2 to both sides. And I'm going to divide by 5. And so we get x equals 2. Now remember, we're not done because our solution has to look like an ordered pair. And so far, all I found is x. So now I'm going to take my x, and I'm going to go back up here to the other equation. And now I'm going to substitute 2 in place of the x, so that we can find out what y is. So this would be y equals 4 minus 1, and I get y equals 3. Now I have an ordered pair. My solution is 2, 3. Okay. Now, let me give you an example, and I'm just going to totally make this up. So we're not going to go through the whole method and solve it. If I give you x plus 3y equals 8, and 2x minus y equals 4. Okay, there's a system of equations. So my question to you is, we don't already have a variable by itself. I don't already have a variable solved for. So which variable would be easiest to rearrange our equation for? I'm going to suggest that the very easiest would be this x, because its coefficient is 1 and it's a positive 1. Now, This y wouldn't be too bad to do, so we could still solve for that y, but it does have a minus sign in front of it. That might make it a tiny bit trickier. So if I were going to use the substitution method on this system, I would write my equation side by side. We'll do just a little bit of it. So I'm writing it side by side. Okay. I would take this equation and I would solve for x this time. So I'm going to have to subtract 3y. So it'd be x equals 8 minus 3y. And so now I would go over here to this other equation, and this time I'm going to substitute in 8 minus 3y for x. So 2 times 8 minus 3y minus y equals 4. And I would go through and I would finish solving. I have no idea what the answer to that is going to come out to. I made that up at the top of my head at the last minute. If you'd like to go through and try to solve it, you can, but I'm not guaranteeing it doesn't come out to some crazy numbers. So give it a try, and we can talk about it when we see one.